Hello everyone, welcome back to the channel. Today we are going to discuss about the most again important basic topic, that is uncertainty in measurement. Last class we have discussed about the nature of matter, classification, properties of matter and their measurement, and international unit. So like SI unit, we have discussed about all these things. While solving the so many difficult questions or difficult database things, we are going to make it is easier. What are those means? These are the first one: scientific notation, significant figure, and rounding off, and dimensional analysis. These are help us in many ways in presenting of data and theoretical calculation. So one by one we'll discuss. The first one is scientific notation. Scientific notation is nothing but it is just a representation in such a way we are going to write like n into 10 to the power n. So what do you mean by n here? N is nothing but an exponent having positive or negative value. When it comes to the capital N, it is just a number ranges from 1 to 10 or 1.00 to 9.99 till it reaches to 10. So when we are going to use these things means, for example, we have a larger value like 2 gram of hydrogen has 0.000000000000166 gram is a mass of a hydrogen atom. This much larger value, how can we convert into smaller value? When we convert it into smaller value, then only data is going to be very easy. Like this much larger value I can convert into 1.6 into 10 to the power of minus 14 gram. This larger value converted into smaller value in the form of n into 10 to the power of small n. This is nothing but scientific notation only. So this is the application of the scientific notation. One by one we'll discuss some more. Scientific notation we can represent in a different way. One by one we'll discuss, just wait for this. Scientific notation is expressed as follows. First one, example, if I took here, there is a value 342.505. This is the larger value. I just want to convert into smaller value. How can I convert? There is a two way. In this sub case I will take, if the decimal point is moving, a decimal point अगर left side पे move हो रहा है तो how many number of digits we will put the decimal after the decimal, whenever we are keeping, that much number will go above to the power 10 to the power, that is 2. Here initially decimal was after 2 point was there. After this, if I am trying to convert into smaller value, the digit is I am trying to shift after 4, means 2 and 4, 2 digits are there, therefore 10 to the power 2 I just mentioned. This is how we are going to represent. When it comes to the 0.000342505, I just want to convert this data in the simple way. So this value also I can mention like 3.42 into 10 to the power of minus 4. So how can we keep this one? See, 1, 2, 3, 4. After 3, I'm just mentioning the value, one more decimal, that is 3 point, means after 3 digit I kept the decimal value, means the 10 to the power minus 4 we are getting. So simple way I want to mention here you people that if the decimal is moving a right direction, then you mention the 10 to the power negative. Just hint you can understand. If the decimal is moving in the left direction, then 10 to the power will go in the positive direction, like positive value will be there. So in this way also you can remember. This is the first application. When it comes to the second one, that is addition and subtraction. Here how we can mention the scientific notation. First thing I will take with the example only, 3.425 into 10 to the power 4 plus 3.425 into 10 to the power of 3. These are just example I took. Keep in mind, to add or subtract number in scientific notation, the power of 10, that is exponent, must be same in all the number. Example here, if you took 10 to the power 3 one side, another side 10 to the power of 4, you can't add these two. So both have a different exponent. First of all, we have to made uniform or same, then only they should be added. For example, 3.425 into 10 to the power 4 I am keeping, and just convert this one into 0.3 into 10 to the power of 4. because then decimal power, sorry, 10 to the power is going to be same. I mentioned now only that if it is decimal is moving left side 0.3, then value is going to be positive. So how many decimal, after how many digit I kept the decimal means only one digit. So 3 was there initially, add one more, then it become 4. Now 10 to the power 4, 10 to the power, both are same, then exponent are same, then you can add the value. So we are going to get 3.425 into 10 to the power 4 plus 0.324 into 10 to the power 4. So finally you can add both the value, that is 3.425 into 10 to the power 4 plus 0.3425 10 to the power 4. You can directly mention the value 3.7675 10 to the power 4. So you are going to get the value, and here 10 to the power 4 is going to get common, so we can get the value in this way also. Same question when it comes to the subtraction. If we have the value 3.425 into 10 to the power 4 minus 3.425 into 10 to the power 3, if it is the case, then we want to solve this type of questions. What we have to do, again exponent power is not same, so make first equal, like 3.425 into 10 to the power, if I keep this one 4, I have to make again this one 3 as a 4, means decimal I have to shift this side, then 10 to the power is going to become 1 plus, that is 0.3425 into 10 to the power 4. You can simplify again, 3.025 into 10 to the power 4, you will get the answer. This is how we have to solve the questions related to scientific notation. Third one is interesting, that is multiplication and division. Multiplication and division in scientific notation. This is also important. Every time we will see these type of application in all the numerical questions. So these are basic, that's why we are discussing one by one. While both operation exponents are added and subtracted as per their positive and negative values, this will become more clear with these following examples. Let's see. Multiplication, whenever we have value, generalized way I am trying to mention here, 10 to the power x into 10 to the power y. If it is a case, then directly have to add 10 to the power x plus y, where x and y are just integers. Just see one by one example related to this. If we have 2 into 10 to the power of 5, one value, another 3 into 10 to the power of 6, one more value, then what I mentioned, you have to just multiply 2 into 3, again 10 to the power of 5 into 10 to the power of 6, they become positive value, just add both value, we have to do the sum, then we will get 2 into 3 6, then 10 to the power 11 is the answer for this. You just need to add both, you will get the answer. Like next 2 into 10 to the power of 5 if I took, but another side 10 to the power minus 6 if it is there. I told again 6 as it is, 10 to the power 2 into 3 we will get 6, and 10 to the power 5 into 10 to the power minus 6. I told you how to add, but here minus is there, means 5 plus minus of 6, then 6 into 10 to the power 5 minus 6 is nothing but you get the value 6 into 10 to the power minus 1. This is how we have to understand. Then third one case, if both 10 to the power minus 5 is there and another is also 3 into 10 to the power of minus 6 is there, then again you have to add, means 6 we will get 2 into 3, then 10 to the power of minus 5 of plus of minus 6. If I added these values, then finally again I am going to get 10 to the power minus 11. This is how we have to add exponent values. When it comes to the last case, that is division. If division, generalized way I want to mention, this is the way. 10 to the power x and 10 to the power y, if it is there, then it is going to be simplified as 10 to the power x minus y. Again x and y as just integers. Go for the example ones. Example number 1, if it goes 2.5 into 10 to the power of 5. This is the one value. Another, I am trying to divide with the same value, that is 10 to the power of 8. So value just simplify, you will get 1 into 10 to the power 5. Denominator value, if it goes above, means it is going to become minus 8. Then finally 10 to the power minus 3 is the answer for this. This is how we have to do the scientific notation in multiplication and division also. One more thing, 2 into 10 to the power of 5 divided by 2 into 10 to the power of minus 8. Then 2 to get cancelled, you left with 1. 10 to the power 5 as it is numerator. Denominator, if it is goes above, then you have to subtract, that is minus of minus 8. Minus of minus 8 if it is there, then it is going to become plus. Then 10 to the power 5 plus 8, we are going to get 10 to the power 13 is the answer. 1 into 10 to the power 13 is nothing but 13 only. This is how we have to calculate the numericals based on this scientific notations. Let's go for some more examples, then we'll understand. If I am having the value, they will directly give express the following in scientific notation. What we'll do, if the question is like 12,500 is there, convert into scientific notation means just mention simplify value the way we want. If I want 1.2 value means then how many decimal points are there? We are coming left, right. If nothing is there means if I mention 1,25,000 is there, dot 00 means it is completely meaningless. So decimal I'm trying to shift one digit, second digit, third, fourth, fifth. So because of that reason, after 5 digit I am keeping the decimal value means then 10 to the power left it is going, so it is going to be a positive, that is 10 to the power 5. Same second case, 0.22 I am trying to convert into scientific notation means then this become 2.2 into 10 to the power minus 1. Why minus 1? Because decimal is now shifting to the right side. Therefore, how many digit? Only one digit. Therefore, 10 to the power minus 1. These are the things we have to remember. Next, we will go for the significant figure. Most important one, we will discuss significant figure. Here, two terms are most important one. One is precision, another one is accuracy. That is, first one, precision. Precision is nothing but it is a closeness of various measurement of the same quantity. It means we just need to understand if it is our target. In this target, I just want to reach this target, but my positions are nearby this. This is one case. Another case, this is my target. Then if my positions every time I am standing nearby this means here precision is very high. Precision is high. Here precision is low. We can again understand the definition. Closeness of various measurement. Here various measurements are there, but it is not nearby each other. They are different position. But here various measurement, even though if I took, all are nearby to each other and they are combined way only. That is the way we can mention it is the precision is high. This is the definition of precision. When it comes to the second one, that is accuracy. Accuracy is nothing but agreement of a particular value, agreement of a particular value to the true value of the result. Means it is approximately near to the value only. For example, if it is my circle and it is my target center point, then if I reached exactly at the center, then accuracy is very high. If one more circle, if it is there, and here if I could not able to reach here nearby to the center means if I reached little bit away from the center means accuracy is low. I have just some images in that I mentioned clearly. We just see one by one. First condition, here we can see that I mentioned if it is a target, first one is my target, then we can see whatever measurements are there, they are little bit away from the target. Second thing, no one is reached to the center of the point. Means another thing, second measurement also, all values are different. They are not at all nearby each other. Means here accuracy is also low. and precision is also low. When it comes to the second case, here as I mentioned, target near कोई भी नहीं है, but जो भी measurement लिया all are in the one way only, or all are present in same position. That is, precision is high but low in accuracy because they did reach the main point at the center of the circle. Here if we saw, all the measurements are exactly near to the center and all are reached to the center also. It means accuracy is very high, but precision is, we can say, they are little bit away from each other. Distance they are maintained properly. So because of that reason we can mention it is low precision. Last one, we can exactly see that all measurements are there exactly at the center and they reach the particular target also. Therefore, accuracy is also high, precision is also high. These are just example related to accuracy and precision. Next we will go for actual definition of significant figure. Significant figure is nothing but it is a meaningful digit. It is meaningful digit which are known with certainty. This is the definition of significant figure. There are some set of rules are also there. Rules of significant figure. What condition? How to find out the significant figure? Some 5 rules are there. Just see one by one. How to determine the significant figure in a measured quantity? First condition it says, or first rule it says, all non-zero digits are significant figure. It means how many number of non-zero digit numbers are there, that means number of significant figure. Example, if I am having 128 centimeter, one value is there. So number of non-zero digit means 1 is there, 2 is there, 8 is there. Therefore 3 is the significant figure. This is how we need to remember. Next, 1.75 centimeter if it is there, that is also here 1, 2, 3. 3 is a significant figure. If 289, 5, 3, if this is the digit or this is the value is there, means total 5 numbers are there, 5 digits are there, therefore it becomes 5 is a significant figure. This is the first rule. Second, 0 to the left of the first non-zero digit in the number are not significant. What do you mean by this, sir? Let's say the example. If decimal is there, after this we have non-zero digit number. For this example, what is a significant figure if they asked? We just need to count after the decimal how many non-zero numbers are there. If, and the condition should be that non-zero digit should be first, then after non-zero digit. Left portion of this non-zero digits के जो भी आता है उनको neglect करना है. Only these after decimal जो भी value है non-zero digits that we have to consider. Here 1, 7, 5 is there, only 3 digit. Therefore 3 is a significant figure for this. Same one more, 0.0017 centimeter. Then left side of the zero digit we should not consider, only right side we have to see the number, that is 2. Therefore 2 is the significant figure for the second example. This is rule number 2. Rule number 3 says zeros between two non-zero digits are significant. We will discuss all these things with the example, then you will understand. For example, if we have the value 1007 centimeter, means here 0 present between non-zero digits. Therefore, here significant figure is going to be, you have to include those 0 also in the significant figure, and then total value is going to be, significant figure for this is 4. Next, 202 kilometer, if it is just unit I mentioned, then significant figure for this is going to be 4. because 0 are also considered because they are present between the non-zero digits. This is how we need to find the rule number 3. When it comes to the rule number 4, 0 at the end or right of the number are significant provided they are on the right side of the decimal point, that is C. Example 6.00 centimeter. Here we have to consider after decimal, or if we got at the right side, left side if it is there, it is not considered. Right side, after the decimal right side 0 is there, that we have to consider, then it is going to become significant figure is 3. Next one, 0.025 centimeter if it is there, then significant figure for this is going to be after decimal point I should get right side of the non-zero digits, we should get 0, then we can consider that also in the significant figure. Here also we got 3. This is how we need to check the significant figure with respect to rule number 4. Last, when it comes to the 5th rule, that is exact number. This is important one. Exact number have an infinite significant figure. What is this? How it is going to be possible? Let's see. Example, if I took 4 pence. Now only I mentioned that 4 pence also I can mention as 4.00. It is also meaning same only. And decimal after we are getting 0 means we have to consider that also. Therefore, if I want to write 4.00, that is also equal. If I am trying to write 4.000000 like this, that is also equal to 4 pence only. Here again significant figure is changing with respect to these number of 0. Therefore, if fixed value is there like 4 pence, you can write after the decimal whatever 0000, if how many times you want, if you want to write, then it is meaning is 4 pen only. But after the decimal there is a right side is there, I have to consider all those 0 as a significant figure. Therefore, infinite number of 0 you can write. Therefore, significant figure for this fixed value or fixed exact number, we are going to get significant figure is 4 for above the values. We can keep on writing this one. We are not at all going to finish these values. Infinite times you can write. Therefore, significant figure is 4 or infinite only. Like that we have to understand. But this ambiguity in the last point can be removed by expressing the number in scientific notation. How so? If you have the value like 4.5 into 10 to the power of 3 meter, then if the value is completely in this scientific notation, then we need to understand that 4.5 and 10 to the power of 3, we have to consider only these two values. By considering these things, we can mention significant figure is 2 for this. Then 4.50 into 10 to the power of 3 meter, if it is there, then significant figure is 3. Like that we have to mention. For example, if you have the value 2.500 into 10 to the power of 3 meter, you should not consider the 10 to the power exponent value. You just need to consider the left side value, that is 2000 or 2.500 into 10 to the power of 3. You should not consider this one. Only value you have to consider. After the decimal, you have to consider 0 also as a significant figure. Therefore, total significant figure for this is going to be 4. This is how we used to do the significant figure, and in this expression, all 0 to the right of the decimal points are significant in this way. So here we completed the significant figure. Then we'll go for the last one, rounding off. After this, we'll go for the dimensional analysis. These are the basic thing actually. While solving the numerical based questions, these simple things are most important one. Without this, a single calculation mistake is done means obviously we lose the marks. Therefore, please don't neglect this one. When it comes to the rounding off, actually dimension analysis we'll discuss later. Rounding off, sometimes the final result of the calculation contains figures that are not significant. Under such cases, final result is rounded off. Like here, 3 important cases are there. One by one we'll discuss. If the rightmost digit to be removed is more than 5, means जो भी वैल्यू को राइट साइड ऑफ द डिजिट एग्जाम्पल में लिया तो 28.87 I take 28.87. If I took here, I want to remove the right side of this digit, that is 7. If the 7 is more than 5, obviously it is 7 more than 5 only, then this value before this whatever value is there 8, to that value we call it as preceding number. I want to change the 7, that is the right side of the our values, and beside that presiding value means उससे पहले जो भी है उस value को we have to add +1, means it is 28.87 and 7 is greater than 5, that I want to remove. Then you can rounding off the value to 28.9. This is the rule number 1 says. Just we need to remember, if more than 1, more than 5, then the preceding number, preceding number means the number which are removing before that whatever number is there, preceding number is increased by 1. Like let's go for one more example. For example, 15.859 is there. Now I want to remove the right side number, that is 9 terminal number. Then rounding off will going to be takes place 15.85 and sorry 86. Why? Because terminal number is greater than 5. Therefore preceding number I have to add 1, that is 5 plus 1, it is going to become 15.6. This is how we need to remember, and this is the rule number 1. Rule number 2 says that if the rightmost digit to be removed, rightmost digit same way is removed and is less than 5, the preceding number means whatever number is there before that number is not changed. Let's understand with the example. Example number 1. If I am having the value 38.282, I want to remove the 2 terminal value, but 2 is less than 5. Therefore preceding value, that is 8, you can't change the value by 1, you just keep as it is 38.8 only. For example, next 15.81 is there. I want to remove the 1, but 1 is less than 5, therefore value is rounding off again as 15.8 is the answer. This is the rounding of rule 2. Third, we are going to discuss about if rightmost digit to be removed is 5, then preceding number is not changed. When? Then that preceding number is supposed to be even. Example, sir. See, 5.25. So exact value is 5. You have to decide preceding number is odd or even. If it is even, don't change. Means rounding off, if I am trying to do, I am going to get the value 5.25 as it is. Sorry, 5.2 only, because 5 I removed. So we got the value 5.2. Same, if I want to change the value, that is 5.35 if I want to write, and I want to do the rounding off for this. Again 5 is the terminal equal, but thing is this preceding number is odd. If it is odd, then add +1, that is rounding off kiya to we are going to get 5.4 is the answer for this. This is the important rounding of rules for the calculation based also. Rounding off का help ही वही होता है कि value को simplify करते हैं and there is no actually change in the value. And here we are going to discuss now some example which are interesting related to the significant figure and the rounding off. When it comes to the addition and subtraction of significant figure, addition and subtraction in significant figures. Seems easy, but somewhere small mistake you people might done. Therefore, just understand with the example directly. We have the some values 1.11, 11.1, 0.11. Add all these value. You will get somewhat 12.32, and इसको approximately I have to write. So why? Because I just want to make the value simplifier, means I can go for the rounding off. Here I want to go for the rounding off, but terminal number is 2 less than 5. Therefore, if I do the rounding off, I am going to get the value 12.3. This is the one thing. Second, when I go for this subtraction, if I have the value 2.56, but then 0.031, I am trying to do the subtraction, means I am going to get the value 2.529. Now, to this I want to go for the rounding off. Here, 9 is the terminal number which is greater than 5. Therefore, preceding number 2, you just add one more, then you are going to get the rounding off value is 2.53 is the answer. This is how we have to go for the addition and subtraction in the significant figure. When it comes to the third case, that is multiplication. Generalized example 15.79. If I am trying to have the value with 6.06, then I am going to get approximate value, that is 95.6874. Now I have to go for the rounding off. Even though you want to remove the value, that is 8, then preceding value how to check. 95.6 is there, but preceding value 6 है तो 8 is the terminal. If I want to remove 8, then it is greater than 5. So preceding value just add +1, that is going to become 95.7 is the rounding off value for the given question. Like division, if it goes, simplified example I am just mentioning, 5.28 into 0.156 into 3. If I am trying to multiply with 0.0428, then I am going to get the value 57.73. Here in this value I want to do the rounding off again, then value is going to become 57.7 because 3 is less than 5. This is how rounding off and significant figure values are going to work. Just want to highlight one more point here, that I just took the value 95.7. I could have taken 95.752, something value might be there. Why I took the significant figure which is here 3 only? Just keep in mind, in the multiplied value, whatever values are there, 2 different values, in that you have to choose least significant figure, which is that. Based on that, whatever answer we are going to get, that should be the same significant figure. Here we have significant figure 3 for 1, another for 4. But I just took the value which is having 3 significant figure, that is 95.7 is the answer. In that way we have to choose. Second question, if it goes, here multiplication I have done, but very least value is going to be that which is only 3 digits. Sir, here 4 digits are there. Yes. Here 3 digits are there. Here 3. Actually it is 3.00. Means it is also 3 digit only. So minimum is 3 only. Here it is 3 only. Therefore, answer supposed to be there in the 3 digit value. That we have to remember. Least value we have to choose for the main answer also. Let's go for these questions. Here they are asking, find the volume. We know that density is equal to mass by volume, and they are asking volume means mass by density. Mass by density. Mass they have given, that is 2.7 gram centimeter cube. It is density actually 2.7 gram per centimeter cube, and mass they have given 4.5 gram. Gram get cancelled, you will get 1.66 centimeter per cube. And here value whatever is there, no, that I just want to convert into least significant figure from numerator as well as denominator. Numerator we have 2 significant figure, denominator we have 2 significant figure. So overall value is supposed to be there in 2 significant figure, but here we have 3. So simplify into 2 means 6 value I have to convert into 7, but here terminal value is greater than 5, therefore preceding value should be added to plus 1, that is I'm going to get the value 1.7 centimeter per cube is the answer. This is how we have to solve the question. Last one, express the following calculation to the proper number of significant figure. They only given the data, again you have to find out. Significant figure is 2, significant figure is only 1 because non-zero digit left side 0 is there, therefore only 1. Here significant figure is 3. So comparatively whatever answer we are going to get, that's supposed to be there in the only one digit, that is one significant figure. Let's go for this. If I am trying to solve this question, overall value I am going to get as, just multiply and divide these values, we'll simplify and we are going to get 1.17 into 10 to the power minus 8 whole divided by 6.4. Overall value I am going to get 0.182 into 10 to the power minus 8, but they are asking proper significant number I have to keep, means I have mentioned now only least significant figure is 1, therefore I am trying to convert this all value into only one significant figure. For that I have to remove the last value, that is 8. 8 is greater than 5, therefore plus 1, that is preceding value, should be added to plus 1, therefore value is going to become 0.8 into 10 to the power, sorry 0.2 into 10 to the power minus 8 is the answer for this. So next we will go for the dimensional analysis. What do you mean by dimension analysis? This is also most important one. This will be helpful for conversion from one unit into another unit. During calculation, we often need techniques to solve the problems involving conversion of unit from one system to another. This method used to carry out this is called unit factor method or dimensional analysis. You can call it as unit factor method also. Second thing, what do you mean by this actually? When it comes for the definition, you can define as the conversion of one set of unit to another which are presenting the same physical quantities is said to be dimensional analysis. Means here we are not at all going to change the physical quantity. Like if I am talking about the one particular paper is having 100 centimeter, then I can convert into meter, then I can convert into decimeter, like this. We can changing the unit only but not the physical quantity, which I am trying to mention in terms of length. Centimeter is also in terms of length, 1 meter is also in terms of length point of view only we will discuss. So these many things are there, we have to discuss one by one. How this thing is going to be helpful in the physical problems in this physical chemistry. For example, before solving the question we should be aware about some basic things like SI unit we know, length, meter, mass, gram, kg, like these things we have to discuss. So we'll go with the first basic things, that is 1 kg is nothing but 1000 gram, 1 liter is nothing but 1000 ml, 1 centimeter cube is nothing but 1 ml, 1 meter cube nothing but 1000 liter, 1 dm cube is nothing but 1 liter, 1 meter is nothing but 10 decimeter, 1 kilometer is nothing but 1000 meter. This is how we can convert the one unit into another unit. If we know all these things only, then only we can convert. And basic or generally we can mention that how to convert from one unit into another unit means they will give some information which quantity is having some length like centimeter, and they will ask convert into meter, like this question they will ask. So information asked means in meter they are asking if you consider, and they will give some value in terms of centimeter. So information asked means this one is equal to, how to find out that conversion? We have to take a formula, information given into unit factor. By this also we can understand the formula. Next one, we'll discuss one by one example, then we may understand properly. Question number 1. Convert 12.12 meters into centimeter. This is their first question. We know that 1 meter is nothing but 100 centimeter. So why we call it as unit factor method means we have a reason also. Unit means 1. So unit factor is nothing but 1. If I took, keep this 1 as it is here, m you bring this side. If it is comes towards right hand side means it is goes to the denominator, that is meter. I can write 1 meter. 1 into 1 meter is nothing but 1 only, 1 meter only. So this we got 1 equal is nothing but 100 centimeter divided by 1 meter. Just mention the value. They given 12.12 meters, we have to convert into centimeter. So 12.12 meter they have given already. We have to keep this one in terms of centimeter. So 12.2 into 1 meter is nothing but, can I write 100 centimeter divided by 1 meter. This already data given in terms of meter only. So 12.2 meter was there. Now I got 100 by 1 meter. Sir, from where you got? Can I multiply above equation as 12.12 meter into 1? 1 is nothing but unit factor. That 1 value now only we got 100 by 1 meter. 100 centimeter divided by 1 meter. So that is I kept value as it is here also. So simplify, meter will get cancelled. I told now information given, it is 12.2 meter given. Then unit factor, we know this 100 by centimeter. So meter get cancelled means we left with 12.2 meter cancel was into 12.2 into 100 centimeter. So we got the unit conversion from meter to centimeter. This is how we used to do. We'll go for some more question, then we may get clarity about this. So now here we can see that if the question like convert 4 inch into centimeter, this is our question. So in this we should know about that 1 inch is nothing but 2.54 centimeter. I told now only whatever unit conversion you have to do, given information, here I mentioned information asked, in which information they are asking, in centimeter is equal to information given, what they have given, mention 4 inch they have given into 1 I can write. So 4 inch into 1 unit is nothing but we can mention 2.54 centimeter is nothing but 1 inch. So this unit we can consider here only. Sir, how you got this one? That is only I mentioned 1 inch is equal to 2.54 centimeter. Keep 1 here only, inch bring this side, right hand side means then it becomes 2.54 centimeter divided by 1 inch. So 1 is nothing but this much value. I am keeping as it is. So how you got this one? 4 inch is given information. Formula also you can see, given information into unit factor. Unit factor is nothing but that value only, 1. So 1 is how much? 2.54 centimeter divided by 1 inch. Now inch get cancelled, then we left with 4 into 2.54 centimeter. Totally you will get 10.16 centimeter. Again, if I want to rounding off, you will get 10.2 centimeter is the answer. From 4 inch is equal to 10.2 centimeter. So inch converted into centimeter. This is how we can convert. Last one example, we will wind up with this example number 3. They are asking one day having how many seconds? We know that one day is nothing but 24 hours. I need to convert into second. Hours it is there. So 1 hour is nothing but 60 minutes, but we don't want in minute. So 1 minute is nothing but 60 seconds. Therefore 1 day is nothing but 24 hours divided by 1 day, 60 minutes divided by 1 hour, and 1 minute contain 60 seconds. Convert all these value. Hour will get cancelled, day will be left as it is. This day will get cancelled, sorry, minute will get cancelled. Then 1 day is nothing but 24 into 60 minute into 60 seconds, sorry, minute get cancelled, so we left with only second. So 1 day completely converted into second. This is how we can do. Take example number 4. 3 days are nothing but how many seconds? Just take it as homework, try to solve and comment below this video. So these are the basic things related to the topic, and they are asking 3 days. Here we can day get cancelled, but here they mention only 1 day, so you can mention directly 1 day is having nothing but 24 hours, so that I can simplify with this. Beside 1 hour contain 60 minutes, then 1 minute contains 60 seconds, so that I can cancel out all the units, then we left with only second. Here also we'll get the 1 day is nothing but these many seconds. Same thing, 3 day means we have to take it as 3 days into 1 day is having how many hours? 24 hours. Like this we have to solve. I hope you will solve remaining things. Just take it as a homework, and please don't neglect any topic from this dimension analysis side, because these are the basic things that will be helpful in the solving numerical questions. So thank you one and all. Please practice more.